NASA's 3-year SMAP mission to measure global soil moisture launches in November 2014. After the protective nose cone, called the fairing, separates, the rocket deploys the SMAP spacecraft. Solar panels, which will generate 14,000 watts of power, unfold and the spacecraft turns the panels toward the sun. Tiny thrusters stabilize the spacecraft. The antenna arm extends from the SMAP spacecraft and the antenna opens. The 6-meter antenna, also called the reflector, is made of strong, thin, gold-plated mesh. The antenna spins so it can measure a wide swath. Employing a combination of active radar and passive radiometer measurements, SMAP covers a swath 1,000 kilometers wide. That's 621 miles. SMAP's radar actively bounces a microwave signal off the Earth's surface to detect physical properties in the return signal. Radar can sense soil moisture through dark, storms, and clouds. And it has a high level of detail, apparent in this 1996 radar imagery of Amazon River flooding, part of a NASA Measures Wetlands project hosted on the Alaska Satellite Facility website. SMAP's radiometer passively senses microwaves naturally emitted by soil moisture, such as in this 2011 radiometer imagery. Together, SMAP's instruments track soil moisture levels over time in any particular location. For example, SMAP tracks changing conditions, such as in this imagery showing that soil can only absorb so much moisture before a river floods. Researchers can use SMAP data to create time series graphs of their study areas, developing different ways to visualize and detect trends in soil moisture levels. In another kind of visualization, this model shows how SMAP data will reveal the planet essentially breathing, taking up and releasing carbon. SMAP data will be freely available to the public starting in spring 2015 from the Alaska Satellite Facility SAR DAC and from the National Snow and Ice Data Center DAC.